So,
oh, just you do the post.
I'm a
Post. Okay, I'm done. One more.
Good evening, everyone. Audible my voice? Hello, guys.
yes, sir. Yes,
Okay,
sir.
okay. Good. Okay. Before starting this section, I will introduce myself. Myself, G. Surya Teja. I have 8 years experience in designing field. Okay. Previously, I worked in so many designing companies, nearly 4 companies. Especially in this particular section, I will discuss about what is the engineering and what is the core engineering, and how to use the CATIA software, and what is the advantages of the CATIA software. And next one is the applications. Next, the history of the CATIA, where it is used, and company structure. Each and everything I will explain this section. Okay. First, what is the engineering? Engineering is nothing but the study of using scientific principles to design and build missions, structures, and other things, including bridges, roads, vehicles, and buildings. Especially in civil engineering, they are the going to the building designing by using the AutoCAD software, StatPro software, Revit, 3ds Max, that like of softwares. But mechanical purpose used the AutoCAD software, Creo, and CATIA software, NXCAD software. Next one ANSYS. These type of the softwares used. In automobile side, used the AutoCAD software, Fusion 360, CATIA. Next one is the SolidWorks software, Solid Edge software, NXCAD. These type of softwares used the automobile and aeronautical and mechanical engineers. Okay. The what is the car engineers? Car engineering means automobile engineering is a branch study of engineering which teaches the manufacturing, designing, and mechanical mechanism as well as operation of the automobiles. Okay, especially car engineering is nothing but the three type of categories. The first one is the interior design, next one is the exterior design, next one is the body design. Okay, first what is the automotive design? The automotive design is an innovative program involving the design of automobiles like cars, trucks, or motorcycles, or lorries, whatever it may be. Both the interior as well as exterior level. Professionals are responsible to ensure all the safety measures associated with the vehicle along with its unique appearances. The study of automobile design combines the aesthetics, economic principles, and aerodynamic properties to carve out the best and most reliable physical body for an automobile. The next point, where it is used, the automotive design applications. Automotive design applications means the softwares where it is used. Okay, AutoCAD, next one is a CATIA, NXCAD, next one is a Solid Edge, SolidWorks. These type of softwares were used in the automotive. Interior purpose used, exterior purpose used, complete chassis design or alloy wheels. Next one is a body designing. Each and everything used the this type of the softwares. Okay, next, what is a company structure? Company structure means, in any company, the majority of departments is a six. For example, I am taking the bench company. In bench company, totally how many departments is there? Six departments are the major important. What are the six department? The first one is a administration, and second one is a research and development. Next one is a production department. Next one is a manufacturing department. Next one is the quality assurance and quality control. Next one is the marketing. What are the responsibilities of the administration? Okay, the main job responsibilities of an administration is to ensure the efficient performance of all departments. All departments means remaining departments like research and development, production department, manufacturing department. Next one is a quality assurance and quality control. Next one is a marketing. These all type of departments are managing to the administrator. Okay, next one, most administrative assistant duties revolve around managing and distributing information within office. This general includes answering the phones and taking memos and maintaining files, and administrative assistants may also be charge of sending and receiving the correspondence as well as greeting clients and customers. Okay, examples, for example, office budgets. Next one is organization company records, salary, shares. Each and everything is responsible to the administration department. What is the research and development? Research and development, mainly three steps are involved. What are the three steps? The first one is a CAD. CAD is nothing but the computer aided drafting or design. And second one is a computer aided engineering. Next one is a computer aided manufacturing. What is a drafting and what is the designing? Okay, drafting is nothing but the creating the preliminary version of your document. Either it's a hard copy or soft copy. It is representation in the 2D. What is the drawing? What is the difference between the drawing and drafting? Okay, drawing is nothing but the without dimensions. Okay, drafting is nothing but the with dimensions. Okay, next one, what is the design? Design is nothing but the concept for entirely new product or existing the modification product. Okay, what is the CAE? CAE is nothing but the computer aided engineering. Okay, computer engineering is nothing but the completely related to the analysis software. Analysis software is nothing but ANSYS, ABACAS, NASTRAN, this type of software is used for the analysis purpose. Okay, but especially drafting purpose, which type of the software is used? AutoCAD is the majorly used. Next one is a designing purpose, which type of software is used? CATIA. Next one is a SolidWorks and XCAD. Next one is a Solid Edge, Fusion 360. These type of software is used for the designing. Okay, but why should you do not use the AutoCAD software for designing purpose? In AutoCAD software, you cannot do the assembly. Only you can create the parts only. Okay, that's why I used the remaining softwares. Next one is a CAM. CAM is nothing but the computer aided manufacturing. These are the separate softwares is there. SolidCAM, NXCAM, different
Excuse me,
types
sir.
of softwares is there. DelCAM. Okay. Next one, what are the
Sir,
responsibilities of the, hello?
sir, your screen is not visible.
Wait. Now visible?
Yes, sir.
Okay. Next one. Next one, production department. What are the responsibilities of the production engineer? Okay, the first point is the coordinating labor and manpower at building sites. The next point, designing layout for further future industrial facilities, determining the cost effectiveness of given programs and mechanical projects, developing plans for mechanical process and systems, drawing up plans for mechanical equipment and missions, inspecting machinery to ensure everything is up to specified code. These are the responsibilities of the production department. Okay, what is the difference between the production and manufacturing department? Manufacturing department is completely related to the material handling. Okay, for example, piston is made up of the aluminum 2014 material. Further future, which type of material is used? What are the properties of the 2021 material? For example, if you use the aluminum 7075 material, what kind of properties is there? Completely related to the material handling in manufacturing department. Okay, the manufacturing engineering or manufacturing process are the steps through which raw materials are transformed into a final product. The manufacturing process begins with the product design and material specifications from which product is made. Okay, next one, what is the quality assurance and quality control? Okay, in any department, any type of company, majorly 6 departments is very important. Okay, what are the 6 departments? Administration, research and development, production, manufacturing, quality assurance and quality control. Next one is the market. Next one, what is a quality assurance and quality control? The quality assurance or quality control inspector works for the company to test sample materials or whatever it may be. It means by using the NDT level 2 techniques. What are the NDT level 2 techniques? Radiography testing, ultrasonic testing, magnetic particle testing. Next one is a visuals testing. These are the different types of the NDT level 2 NDT testing. It is a non-destructive testing. By using these techniques and check the quality control. Okay. Next one is a marketing. The action or business of promoting and selling products or services, including market research and advertising. Okay. That is completely related to the marketing strategies. Okay. What is the engineering based on? First, if you create the any component or any design, first need the component. Next one is a designing, drafting, modeling, analysis, simulation. Next one is a presentation. These are the cyclic process for the any product to implementation, the new designs, whatever it may. Next one is the types of the drawing. What are the types of the drawing? Basically, 2 types of the draftings. 2 types of the draftings. One is a manual drafting, another one is a computerized drafting. What is the difference between the manual and computerized? Manual is nothing but the in 1972 before 1977 before every person used the manual drafting, because of in 1977 to 1982 they are doing the AutoCAD software programming. After 1982 officially released the AutoCAD software. From 1982 to up to this year, they are using the AutoCAD software for especially drafting purpose. Okay, before they are using the manual drafting. Okay, computerized drafting is nothing but the AutoCAD software or remaining softwares. Next one, this is the manual drafting and this is the computerized drafting. Next one, what is a CAD? Computer aided drafting or designing process. Okay, what is the isometric? Isometric is nothing but the pictorial view representation as a 3D view in 2D workbench is called the isometric view. Okay, what is the difference between the isometric and 3D modeling or design? What is the difference between the isometric and 3D design? Isometric is a just view, but 3D object is completely, it shows the all types of the views: front view, side view, rear view. Isometric, in isometric view only shows the 3 types of the views: top view, front view and side view. Okay, isometric is just view, like a front view, top view, side view. That type of the view is shows here the three types of the views. Okay, next one. Already I told you. First, before starting the CATIA software, just I will introduce about the what is AutoCAD and where it is used, how to use the drafting software. Just I will explain introduction. What is the AutoCAD? AutoCAD is the most powerful software in field of the drafting. All other design softwares are based on it. It has launched in Autodesk company in US around 1982. Who invented this AutoCAD software? John Walker is invented this AutoCAD software. Okay, here you can do the drafting and annotation, isometric, and 3D modeling. These three concepts you can do in the AutoCAD software. But this 3D modeling is the part modeling, not the assembly. In AutoCAD software, you can only create the parts, not assembly. Okay. Next one is the what is the difference between the drafting and annotation? Drafting is nothing but you can create here the object with specific dimensions. But in specific dimensions, you mention by using the annotations. Annotations is nothing but the dimensions. Next one is a text. Next one is a leader. These are called the annotations. Okay. Next one. I already had told you isometric drawing 3D. Okay. Especially designing purpose, use these softwares: CATIA, SolidWorks, Creo, NXCAD. Next one is a Solid Edge. Coming to the CATIA software. What is a CATIA? Computer aided three-dimensional interactive applications. This CATIA software developed in 1977 by French aircraft manufacturer Aviance Marshall Dassault. This is a multi-platform software. Multi-platform software is nothing but it is used CAD, CAM, and CAE. This is the commercial software developed by the French company Dassault Systems. Next one. In CATIA software, we can do the computers also. Computer aided engineering is nothing but the analysis process also. Okay, so many people are called the CATIA software is used only the designing purpose. But in CATIA software, you can do the analysis process also. Okay, in ANSYS software, you can do the modeling part also and analysis part also. But every person called the ANSYS is only used for the analysis purpose. Okay, ANSYS is used for designing and analysis purpose. CATIA is used for designing and analysis purpose. Okay, next one. So many applications use this CATIA software. In CATIA software, overall 77 modules is there. How many modules? 77. But especially mechanical, automobile, aeronautical purpose used the 6 modules. What are the 6 modules? The first one is a sketcher, and second one is a part design, and next one is a assembly design. Next one is a wireframe surface design. Next one is a sheet metal design. Next one is a drafting. What is the difference between these 6 modules? I will explain later. Okay. First, what are the applications of the CATIA software? What are the applications? Every places use this CATIA software, especially aerospace, automotive, shipbuilding, industrial equipment, high-tech, energy process and utilities, marine applications. Every places use this CATIA software. What is the difference between the sketcher, part design, assembly design, wireframe and surface design, sheet metal, and drafting? The first one, sketcher. The sketcher is used to create the 2D sketches of designs and apply constraints to the sketched geometry. Next one. In AutoCAD software, basic drafting and annotation. This drafting process here called the sketcher. Okay, in AutoCAD software, we call it the drafting. It is nothing but some tools is there like draw commands, modify commands. Next one is inquiry commands, properties. Next one is the layers. These are the different types of options in the AutoCAD software. Here we call it the sketcher. Okay, in sketch tools, next one is operations, constraints, and profiles. These four toolbars called the sketcher. The sketcher is now the main environment for the developing the 2D profiles. If you want a 3D object, then need the 2D profile. Without 2D profile, you cannot do the any type of the 3D product or 3D component. Okay, in every place, like a wireframe and surface design or sheet metal or part design, whatever it may be, if you want any product or any object, any part, any component, then need the sketch. Without sketch, you cannot do the any type of 3D product. The next one, the sketcher provides a flexible environment for the creating and modify 2D geometry. Basically, this CATIA software is a parametric modeling software. What is the difference between the modeling and parametric modeling software? Modeling software is nothing but it is not editable. For example, AutoCAD software is the modeling software. For example, if you create the piston, you cannot modify easily. But in CATIA software, you can modify very easily. For example, already you created with certain dimensions. Just you go to the part body and go to the specification tree. Just you change and direct go to the update option. Easily modified. Parametric is nothing but you can editable very easily. That is the main advantages of the CATIA software. And next one, sketcher models. Okay, these are the types of the sketches. Okay, next one, coming to the part modeling. Part modeling is nothing but the solid. The part design application is used to create the solid models of parts. Solid parts are usually created from 2D profiles that are extruded or revolved to from a base features. Okay, it is in part design also totally 4 toolbars is there. The first one is a sketch based features. Next one is a dress up features. Next one is a transformation features. Next one is a reference element. These four toolbars are called the part design workbench. The part design task is tightly integrated with the 2D sketching tools. Completely related to the sketcher and part design. Just to create the, for example, one square. Then you go to the part design, apply the extrude option or pad option. Then it converted into the cube. It is completely related to the sketch and part design. A library of features is provided to allow user to add additional details to base part. And in CATIA software, some libraries is also available. Library is nothing but the default some tools is there. Like nuts, bolts, these are the default tools is inbuilt in the CATIA software. Next one, parts can be modified by selecting their features in the specification tree. Already I told you this is a parametric modeling software. This point is main important. Parts can be modified by selecting their features in the specification tree. Easily modified. The parts stored in files with the extension is the CAD part. In sketcher, part design. Next one is a sheet metal. And next one is a wireframe and surface design. These all are the saved in the .CAD part. For example, in MS Office, we saved the MS Word in the Word format. Excel, you've saved in the Excel format. Like in CATIA software also, you can save in here the CAD part. Very important. Okay, next point. Part models. What type of the models you can create in the CATIA software? See here, landing gear, radial engine. Next one is like bus and gears, spur gears. These are the created in the CATIA software. These are the some the assembly parts is there. Some are the parts. Number of parts here you can assemble by using the assembly workbench. Next one, See here the assembly design. What is the difference between the part and assembly? Part is nothing but the single component. Product is nothing but the combination of the parts. Guys, are you following? Hello?
Yes, sir. Yes, sir.
Okay, good, good. Thanks for response. Next one. The assembly design application allows you to create a product model for a number of separate parts. The parts in a product assembly are not joined together, but assembled as they would be in a physical assembly. The product assembly structure is a main product in the CATIA software. Okay, here the mainly existing component and existing component with a position. You use these two options existing the components in the assembly workbench. Next thing is the constraints can be applied between the parts in assembly to define relationship between them. It is relationship between them means, for example, already one component is existed. Another component is where it is fixed. For example, concentricity or perpendicular or parallel, where it is fixed. That positions are the same in the constraints. Okay, here very important. Here also totally 3 toolbars are very important. The first one is a product structure tools. Product structure tools is the just you component you are existing the by existing in the assembly design. And second one is a constraints. Constraints is nothing but the you restricted the component with certain position. And next one is a manipulation toolbars, move toolbars, some toolbars is there. Okay, this is the assembly models. Okay, different types of the components is there assembled by using the assembly models. What is a wireframe and surface design? Wireframe is surface design is nothing but the here you can do only surface designs. Surface designs is nothing but the propeller fans, propellers, or helicopter outer structures, car interiors, car exteriors, car seats. Okay, different types of designs you can create by using the wireframe and surface design. Okay, next one, these are the surface models. See here, this is the exterior of the car outer part. And next, this is the impellers. Okay, drones, different types of components created in the wireframe and surface design. Because of the some components are the created in the sheet metal, some components are the created in the part design workbench, and some components are created in the wireframe and surface design. You based on the application, then you use the this type of the modules. Okay, and next one is a generative sheet metal. Sheet metal is nothing but the each step to way to learn the key sheet metal environmental. Especially here you can create the flanges, couplings, okay, bend allowances. Next one is a sheet bends. This type of the features available in the sheet models. See here, like this sheets are bends by using the sheet metal options. Okay, next one, what are the advantages of this software? So many advantages of this software. The first one, easy to draw. It is compared to the remaining softwares like SolidWorks or CAD. Next one is a Fusion 360. Or remaining softwares compared to the another softwares, you can create very easily in CATIA software. And second part is a less time consumption compared to the another softwares. You can create within short time. Next point, accuracy and precision. Exact values you can create and exact values. It is nothing but the 0.0001 accurately you can create in the CATIA software. Easily modification because of this is a parametric modeling software. Next one is a less error. Next one is a dimensions and coloring. Dimensions is nothing but the in CATIA software. In CATIA software, In drafting workbench, we apply the dimensions, diameter, radius. Next one is aligned dimensions. Next one is a linear dimensions. Next one is angular dimensions. Different types of options available in the drafting workbench. Because of this final product, you forward to the production department with specific dimensions and with specific GD&T concepts. Everything mentioned in by using the drafting workbench. And next one is a colors. In any product, we apply the colors also. And next one is a rendering and lighting. Rendering is nothing but the create the photorealistic images. Create the photorealistic images is nothing but the, if you create the any component, then you convert it into the image like JPG or PNG format. Basically, if you are the save the part or product, CAD part or CAD product, but rendering is nothing but the object is saved in the JPG or PNG format. And lightings, if you create the any car or if you create the any object, then you you apply the lightings and you just show the colors after apply here the rendering option. Okay, it appearance is very looks. Next one is the coming to the analysis part. Guys, following or not? My voice audible?
Yes, sir.
Yes, sir.
Yes, sir.
Good. Okay. Coming to the computer aided engineering. This is very important. Already you know what is a CAD, what is a drafting, and what is a design. Now I am going to hear the computer aided engineering. 1 minute. Okay, computer aided engineering. Which type of the software is used for the CAE? Like ANSYS, ABACUS, Nation, this type of the software is used. ADMAS. Okay, ADMAS software is used for the dynamics purpose. In ANSYS, you can analyze the structural and thermal analysis very easily. What is the difference between the structural and thermal? First, what is the ANSYS? ANSYS is the product analysis software. It is widely used for the designers and analysts. Okay, what is the difference between the structural analysis and thermal analysis? Great. Okay, ANSYS is the product analysis software. It is world leading, widely distributed and popular commercial and CAE package. Basically, analysis purpose, so many softwares is available, but especially ANSYS is widely used every places. Okay, because of the it is a reasonable cost and it comes the good outputs. Okay, this ANSYS software, where it is used, what are the applications? The first one is a aerospace, next one is a automotive, next one is a manufacturing, next one is a nuclear, next one electronics and biomedical. Biomedical means, for example, implant designs. Okay, just I will show on PPT. Okay, this PPT is visible or not?
Yes, sir. Visible.
Visible. Okay, good. Okay, this is a biomedical applications. For example, modeling and structural analysis of ankle joint on different loading conditions. Then you create the implant designs. For example, see here, this is the ankle joint. In ankle joint, totally three types of components is there. The three components is tibial component. Next one is a mobile bearing. Next one is a thalar component. These three type of components created in by using the CATIA software. Okay, after you go to the analysis. For how to do the analysis, just you fix it the bottom side and apply the top side in the human loading conditions. Human loading conditions is, for example, you take the 100 kgs, 100 into 9.81, 981 newtons. Consider the input condition. Then apply. It is a withstand the human weight or not, using the various materials like steel material or titanium material or cobalt chromium material. Okay, different types of materials you check the in ANSYS software. Finally, what are the outcomes in ANSYS software? Outcomes is nothing but the like Weinmeister stresses. Next one is the shear stresses. Next one is a total deformation. Next one is a strain. Next one is a different loading conditions we observe in the ANSYS software. Okay. Next one, another example. 1 minute. This is another example. Dental implants. Okay. This type of the dental implants also created by using the CATIA software. Okay. This is a basically cylindrical taper type implant. Then you check the only cylindrical type of implant. And you change here the threads. Different types of researchers are doing by using designing the ANSYS and CATIA softwares. Okay. This is the complete this type of the implant design also using the CATIA and ANSYS software. See here, these are the software. These type of components. This is a implant and this is abatement. And next one is a crown, denture. These all parts are fitted into the denture. In denture also two types of bones is there, cortical and cancellous bone. Okay, complete part design using the CATIA software. And by using the ANSYS software, you check the ANSYS where the loads are obtained, stresses are obtained, and deformations are obtained, shear stress and strains, everything observed by using the ANSYS software. Okay, this is one example. Another example. This one is the human knee joint. Okay, knee implant. This type of the implants also designed by using the CATIA software. This is the implant. Okay, this one is the implant using the CATIA software and analysis by using the ANSYS software. See here. Here totally three components is there. Femoral and plastic spacer. Next one is a table component. And next one is a designing process. How to design this this type of the knee implant. Here one software is there. That is a mimic software. Mimic software, you can take in the dimensions, exact dimensions from the patients. Okay, actually, for example, 15 years person have the some type of dimensions, and 40 years age person is he have the some type of dimensions. Then every human being dimensions are the different. Then you scan, and after go to the mimic software and you measures the dimensions and draw in the CATIA software. This is a systematic. By using the ANSYS software, here we apply the 2500 newtons. Another one is a different loading condition, 3500 newtons. And observe here the static analysis fixed at the bottom side and apply the top side 2500. Finally, we observe here the stresses, strains, deformations, which material is the best. See here, I comparison here the four materials. Like what are the four materials? ABS, SS316 material, titanium 6Al 4V material, and TI6Al 7NB material. Different types of materials is there. Finally, which material is the best? You observe here, which have the lowest stresses. This TI6Al 7NB material is the best material. So this material is the concluded for the this knee implant process, easily manufactured by using the CAM process. Okay, different type of examples is there, like okay, next point, what are the types of the engineering analysis? The first two types is very important. The first one, structural and thermal. In structural analysis, again 5 types of there. The first one is the, see here, first what is the structural analysis? In structural analysis, first the nodal degrees of freedom, displacement are calculated, and then the stress, strain, and reaction forces are calculated from nodal displacements, the classification of structural analysis. Next one, structural analysis broadly classified into the 5 types. The first one is a static analysis, and next one is a dynamic analysis, and next one is a spectrum analysis, next one is a buckling analysis, next one expert dynamic analysis. What is the difference between these 5 type of analysis? Okay, coming to the static analysis. In static analysis, the load or field conditions do not vary with respect to time. Therefore, it is assumed that the load or field conditions are applied gradually, not suddenly. For example, every load and every results are converted into the F is equal to Kx. F is equal to load matrix, K is equal to stiffness matrix, X is equal to displacement matrix. What are the dynamic analysis? Dynamic analysis is nothing but when a load or field conditions vary with respect to time. In static analysis, it do not vary with respect to time. In dynamic analysis, with vary with respect to time. Again, in dynamic analysis, broadly classified into 3 types. The first one is a modal analysis, and next one is a harmonic analysis, and next one is a transient dynamic analysis. What is a modal analysis? In modal analysis, it is a family of the dynamic analysis. Here, you can analyze the total deformations at different frequencies. It is nothing but the vibrations, related to the vibrations. For example, take the one object, car chassis. In, for example, 5000 Hz, how much deformation is obtained? This type of analysis, you choose the modal analysis. In static analysis, just you fix the one side and another side you apply the loading condition, just you observe the stress, strain, deformations. This type of analysis we go to the static analysis. Okay, what is a harmonic analysis? Harmonic analysis is nothing but it is a combination of the static and modal analysis. Here you can apply the loading conditions, at the same time you fix the apply here the frequency values also. In harmonic analysis, you take we apply the frequency values are the input. Then you find out here the stresses, strains, deformations at different frequency levels. transient dynamic analysis. It is one of the dynamic analysis, part of the dynamic analysis. Okay, it is with respect to time. Okay, and next one, above equation is called the force balanced equation. For the linear system, if the elements of matrix are the function of x, the system is known as non-linear system. Non-linear system include the large deformation, plasticity, creep, so on. The loading conditions, what are the inputs and what are the outputs? Very important in ANSYS. In ANSYS, totally how many steps is there? 3 steps is there. What are the 3 steps? Pre-processor, solution, and post-processor. In any module, for example, in thermal analysis or static analysis or modal analysis, any analysis, you follow the must and should 3 type of process. The what are the pre-processor, solution, and post-processor. Pre-processor is nothing but the input process. What are the inputs to analyze the object? The first one is the engineering data. Engineering data is nothing but the material properties. Material property is nothing but the every object has certain properties. Like wood have certain properties, glass have certain properties, metal have certain properties. What are the properties? Density, Poisson's ratio, Young's modulus, tensile strength, yield strength. These are called the properties. Thermal conductivity, specific heat. These are the properties. Okay, then these all values are applied in the preprocessor in engineering data. That is called the material properties, called the engineering data. In preprocessor, the second step is the create or import geometry. Already I told you, in ANSYS software, you can create here the objects or imported the objects. Okay, ANSYS is used for designing purpose and analysis purpose. But maximum every person doing importing process. It is nothing but the CATIA file, CATIA or SolidWorks or CAD. Every object save in IGS format. Then open into the ANSYS software. Okay, IGS file is opened in the ANSYS software. Next, the third step is the model. In model, you convert it into the nodes and elements. And next one is the fourth step is the boundary conditions. Boundary conditions is nothing but the where it is fixed and where it is the applied the loads. Where you apply the movement. Conditions are very important in ANSYS. Okay, these 4 steps are called the preprocessor. And second one is a solution. Solution is nothing but it generates automatically inside in ANSYS. And next one is a post-processor. Post-processor is nothing but the results. What are the outcomes from ANSYS software? Stresses, strains, deformation, shear stresses, temperature distribution. Next one is the total heat flux. These are the outcomes of the ANSYS software. Next one, coming to spectrum analysis. Okay, this is the extension of the model analysis. And here used to calculate the stress and strain due to the random vibrations. Random vibrations is a continuous vibrations whenever applied on object, continuous vibrations. It is a random vibrations. The structure is withstanded or not. Which type of the structures you do the analyzed in ANSYS software? For example, trusses, heavy structures, heavy type of chassis. These type of structures analyzed by using the ANSYS software by using the spectrum analysis. Okay, especially you can analyze the structure is withstand or not while it forms the earthquake. It's survey or not. This type of analysis use the spectrum analysis. Okay, buckling also same. This type of analysis is used to calculate the buckling loads, mode shape, and a slender structures. Slender structure is nothing but the large thin structure. Large thin structure is nothing but the chassis, heavyweight chassis. For example, 12 tires lorry, 14 tires lorry chassis. This type of chassis analyzed by using the buckling analysis. And next one, explicit dynamic analysis. Explicit dynamic analysis is nothing but here you can calculate the stresses, strains, deformations while two objects are crashed or explosion. This type of analysis using the explicit dynamic analysis. Okay, in thermal analysis also totally two type of analysis is there. First, what is thermal analysis? The thermal analysis is used to determine the temperature distribution and related to thermal quantities such as the temperature distribution, amount of heat loss or heat gain. This type of analysis used the thermal analysis. What are the outcomes of the thermal analysis? Okay, outcomes are the temperature distributions. Next one is the total heat flux. These are the outcomes of the thermal analysis. Completely related to the heat transfer modes. Heat transfer modes is nothing but the conduction, convection, radiation. Completely related to these three concepts. But what is the difference between steady state thermal analysis and transient thermal analysis? In this analysis, system is studied under the thermal loads. It is the when a load or field conditions, like thermal load or field conditions, do not vary with respect to time is called the steady state thermal analysis. In transient thermal analysis, here vary with the temperature, like vary the thermal loads. For example, at 5 seconds, how much heat is the transferred? For example, 10 seconds, how much temperature is lost? Here completely related to the time, vary with respect to time. That is the thermal analysis. Okay, just I will explain one example. Just show the CATIA software. Okay, everybody visible CATIA software.
Yes, sir.
Okay. In CATIA software, this is a CATIA software. In CATIA software, totally 77 modules is there. Module is nothing but the sketcher is the one module, part design is one module, assembly design is one module, next one is a drafting is one module, next one is a sheet metal is the one module, wireframe and surface design is one module. Different types of modules is there. But automobile and mechanical, next one is the aeronautical. These type of engineering especially used these 6 modules. The first one is a sketcher, part design, assembly design, wireframe and surface design. Next one is a sheet metal design and drafting. Just I will explain one component after I will close this section. Okay, just go to here the mechanical design. First to go to here the part design workbench. Just click here. Now mention here the name. Okay, just mention the CATIA. Enter. First, Whenever open this CATIA software, automatically here shows the here displays the XY plane and YZ plane and ZX plane. XY plane is represented the top view, YZ plane is represented the front view, and ZX plane is represented the side view. Just I am selecting here the YZ plane. Now go to here the sketch. Just I will create one component. How to create the piston? First of all, create here the circle. After create here the rectangle. Now go to here the trim option, just to create here the trim. After go to the zoom, then you create here the rectangles. Okay, I am creating this part using the sketcher workbench. Okay, first create here the rectangles. Select, after go to here the translate option, then click here the instances. How many instances for apply here? Just click here. Again select, go to here the translate, specify the base point. Now create the another instances. Now go to here the trim option, click here. Actually in piston have totally 4 rings is there. Piston rings is 4. Top side is 3 and bottom side is 4. Just I am saying roughly. Okay. Next, go to here the profile. Now create the object. Now go to here the trim option. Delete here the lines. Just I created the sectional view. Okay, sectional view. Now go to the existing workbench. This object I created in sketcher workbench. Okay, now I entered into the part design workbench. In part design workbench, then apply here the shaft. Now select here the axis. First of all, select the object. After go to here the select the axis. Then enter the click OK. See here, this is the object. In sketcher workbench, I created the sketch. In part design workbench, I created the shaft option. It's converted into the solid. Okay. Up to here, okay.
Yes, sir.
Okay.
Yes,
Thank you.
sir.
Thank you, everyone. Tomorrow I will conduct. SAR will be intimate when section will be conducted. Okay. Thank you. Thank you, everyone.
Thank you, sir.
Okay, sir.
Thank you,
Thank
sir.
you so much, sir.